Hello Algebra 2 students. We're going to continue looking at proportions in this video. So in the last video you've already seen an example, a geometry example where you have two similar triangles, and one of the triangles they've told you all the coordinates of the vertices, and the other one has one missing vertex, and you have to develop a proportion to find that missing vertex. Okay. So the other problem that you've already seen is one involving a hill and or a cliff and someone's shadow, and you need to create some triangles and a proportion to solve for the height of the cliff. Good? So that's what's in the other one. We're going to look at two other relevant problems to our assignment now that involve proportions. Proportions are hugely widespread and can be used in a lot of situations, even though they're so simple. So the first one is a downloading file, okay? Something we're all familiar with. We've all got those loading screens. Actually, to program a thing that's accurate in terms of how it tells you how much time is left on downloads is really, really hard. We're going to kind of ignore all of those things at this point. So we all download files. So this is a pretty big one, like a video or something, 240 megabytes, right? So we're going to say it's downloading at a constant rate. Do all files download at constant rates? What do you guys think from your experience? Sometimes don't they like download really fast for a while and then they slow down because something happens, and then they speed up way even faster than before? That's not constant. So we're going to pretend we're in an idealized world where internet connections and bandwidth remain constant, okay? You got me? So we have really, really good internet or really, really bad internet that never gets better. Okay? That's what I mean by constant rate. If this didn't say constant rate, actually a proportion would not work to solve this problem. So that's kind of a little subtlety that you guys don't have to worry about in the assignment. Just a bit of science. All right. So the information we know besides the file's original size is that after 3 minutes, 20% of the file is downloaded. So we're supposed to answer how much time remains in that download. Okay? I think we could do this a few different ways, but we want to use a proportion. So on your assignment, every one of these problems is going to involve a proportion. So that's what you should do. You don't have to copy them down if they're a word problem, right? You're going to write and set up a proportion. So you're going to have blank equals blank. And then you've just got to figure out how to fill in those boxes. There's all kinds of right ways to do it. Let me demonstrate. So we've got the file size, we've got some time, and they're asking us about time. There might be some extra information in this problem. It's a little bit tougher than some of those other ones I did in the first video. But what are we really being asked for? Time. So I think we better get time in there. Does that make sense? What do you guys want to call the unknown? X or T? Love X. All right, we'll stick with X, even though I think T for time would make more sense, but X is comfortable. So let's just put X on the top. Notice I didn't think about where to put it at all. So now we need to choose what we're going to compare it against. What do you guys think the unknown time should compare against? Is there anything natural? So Kaylee, you're saying 20%? It's a time, it's not a percentage. 3 minutes is a time. So to me, I would naturally be comparing to the other time. Now you can compare that different ways. You could put the other 3 minutes over here, or you could put it down here. I'm just going to say I put it down here. Once I've made my choice on the left-hand side, then I'm locked in. Now I have to be careful, okay? Now I have to see what matches with what. So this was, and it sometimes helps to write it down. Like I said, define your variables. You don't have to in this assignment if you don't want to, but X was the unknown amount of time that remains. 3 minutes was the time that's gone by. So what other number corresponds to the total time? We got that 20%, right? So somehow we're going to use that 20%. So how are we going to use that? Is that 20 like the whole thing, the part? Does it correspond to the X or the 3? Corresponds to the 3. So shouldn't we put the 20 down here? And if something's a percent, and a lot of your problems in here are not going to be percentages. You're just going to have numbers. Those will be even easier, I think. But if it's a percent, it already has a built-in comparison factor. It's out of how much? 100. Does that make sense? So really, did we even ever have to think about the 240 megabytes in this problem? No, I think we could have done it a different way and used that as well and set up a different proportion. We didn't have to this time. So a percent already has a built-in percentage. So we were going to use our strategy we just learned to solve proportions. What would we multiply by with on both sides? 3 and 20 are totally different, right? So 60. And see what happens. 60 over 3 is 20. 60 over 20 is 3. There you go. So x is 300 over 20. Can you guys help me with the calculator there, or just do it in your head? What is it? 15? And units. So at this point, on all of your proportion problems, and most of the time this year, if you're doing any kind of application, you should have units, number one. If you don't, you're going to miss some points. If you don't have it on the test, you're going to miss a lot of points. Okay, make sure you get your units on there. And also, is this a reasonable answer? Think about the numbers involved. If we downloaded 20% of the file in 3 minutes, might like the rest of it take 15 minutes?
Because it's 20% of it in 3 minutes.
Right.
You could also do 20 times 4.
Right. And it would be real easy to follow this up, like if they asked us, okay, now also how much of the file remains, we could work that 240 number, do another proportion, and come up with that just as easily. So there's one example. Here's another example, which I'm a little bit less sure about the scientific validity of, because I was just picturing energies versus velocities. I gave you at least one problem that kind of comes in a table like this. What I like about this kind of problem is it gives you, again, a lot of distracting information, and you don't need it all. So let's imagine that this is the velocity of some kind of moving object, maybe like a car, and this is the energy of that object when it hits something, maybe like a wall. All right? So what we want to do is come up with a question we can answer with a proportion. The only thing I'm a little bit wishy-washy with is velocity and energy from physics are not constantly related. They're actually related with a parabola. So this is not totally scientifically accurate at all, but it goes through the concept of a proportion, okay? So I couldn't think of anything better off the top of my head. Anyway, so we need to ask a question, like, let me see. Look at this guy. I have one similar. Units on these too, right? You guys know a unit of energy from middle school or any other science class? Any unit of energy. Newtons are force, that's a good guess. Watts is energy per time. That's a great guess. Joules is correct. That's the SI unit. Very nice, Mr. Roman. Joules is the best unit of energy. There are other ones like horsepower. Oh, that's power. I'm wrong. What is the English unit of energy? I never use it ever in I teach physics, so you must just need to know joules. Velocity, you guys know some units of velocity, like what? Think cars. Miles per hour, that's English though. Most of the time we never use that in physics. The most acceptable one is meters per second. Okay, so we'll pretend these were in meters per second. Anyway, so what's a reasonable amount of energy to be released from an object traveling, I don't know, what do you guys want to pick? How fast? 50? Should you say 50? Say 50. 50 meters per second. So even though we couldn't really do this physically with the proportion, we're going to try it. Which means our estimate will probably suck. But oh well. So, proportionally. We have 50, so shouldn't we probably get it in our proportion somewhere? I think so. Sometimes it helps to think ahead. What is the reasonable amount to be released from an object traveling 50? I don't know. Does it matter if we put it on bottom or top? I don't know. Move it on the bottom. I don't think there's a good reason for either one. So then, what are we trying to answer? How much energy there is. You got it. You got it. What is the energy? So maybe we'll make that our variable. So should we put that like here, here, here? All right, let's put it there. Now we're locked in. Now we got to make sure Things actually compare. That's what a proportion is. Okay? So what compares to that? I think we can use multiple different parts of this. If we want to get the best estimate, since I said this is technically not constant, we should use something close. So which one of those is closest? Which one of those data points is closest? 10 and 5. You're correct. Either one of these is probably going to give us the best real estimate. But in the problem that is like this in your book, it's I think a chemistry problem, it won't matter. So anyway, so what should I put here and here? 5 over 10, is that right? Yeah, because 5 is an energy and 10 is a velocity. That's very simple to see how they match. Okay, if I had to pick this one, I'll probably get something really close, but in the problem I gave you that's actually accurate, it'll be exactly the same. So, I'm just going to multiply by what? 50? Will work, because 10 and 50 both go into 50. So on the left-hand side, that cancels, and you get E equals 50 over 10 is 5. So we have that 5 and this 5, and we get E equals 25. And we'd miss a point if we had that on our homework, because why? Because there's no units. The units are joules. And even though this was made up by me without thinking enough, I think that's still reasonable as an answer, isn't it? Because at least 25 is between 5 and 27. We knew it had to be somewhere in the middle. Okay? So, there's a couple more examples. If you did just watch this one and need some more, look at the first video. See you next time.